So let's continue with that example of f of x equals negative x squared plus 25 on that interval negative 1 to 5. I do use my own notation in this. This is not notation that's in the book. The notation that I'm using is right here. So anytime you see the letter, if it's an L, that stands for left endpoints, an R stands for right endpoints, and then I believe I use an M for the midpoint. I might use a C, but we'll look in just a little bit. Okay, so it says approximate the area of a region bounded by the x-axis and the curve of f of x equals negative x squared plus 25 on the interval negative 1 to 5 using L3. Again, the L stands for using the left endpoint of each interval, and the 3 stands for the number of rectangles. So it says that is approximate the area using 3 rectangles with the left endpoint of each rectangle to determine the height of the rectangle as depicted below. Okay, so what are we going to do? Well, we have a couple of things to do. First thing we want to do is consider how many rectangles did they want. Well, they wanted 3 rectangles. Which endpoints are we going to be using? Well, we're going to be using the left endpoint. So this is all information that we need to know without a doubt, okay? So what's the next thing we should do? Well, you should probably find out what is the width of every single rectangle. And to find the width of every single rectangle, that's denoted as delta x, right? All you're going to do is the right endpoint minus the left endpoint divided by the number of rectangles. So the right endpoint on this one is a 5. We're going to subtract off the left endpoint, which is a negative 1. We're going to divide it by the number of rectangles, which is 3. So that gives me 2. This is my width of every single rectangle. Okay. Now, if I didn't have this picture, because on the test you're not going to be given the picture, what would I do next? Okay. So what I'd do next is I'd draw a number line, and I'd label it with the start A, which is negative 1, and the end B, and then I'd think, okay, well, I need 3 rectangles. Well, to get 3 rectangles, I need to put in 2 partitions. I want to try to make this visually look like what it would be, so what I'm trying to do is equally space those, and if you could see, that would generate 3 rectangles. Now I need to consider what would the labels of those rectangles be, and here's where I was trying to explain on the previous page. All we're going to do is add this delta x value every single time. So go from negative 1, I'm going to add the width of the rectangle, which is 2, so negative 1 plus 2 is 1. Sorry, let me put that in pen. That's a 1, and then 1 plus 2 would be 3, and 3 plus 2 would be 5, so it seems that I have my labels correct. So there's my labels on my interval, and I need to think about this. So I have my first rectangle, my second rectangle, and my third rectangle here. That'd be 3 different rectangles. I don't see the height of the rectangles, but these are the widths of the rectangles. And for each one of those rectangles, I want to use the left endpoint. So what I'm going to do is come in and I'm going to circle the endpoints that I want. Of the first rectangle, I'm going to use the left side to determine the height. Of the second rectangle, I'm going to use the left side of that rectangle to determine the height. And of the third rectangle, I'm going to use the left side of the rectangle to determine the height. Okay? So again, how do I determine the height? I plug in the function value. So if you're looking at the first rectangle, think about that first rectangle here. If I want to find the height of that rectangle, I'm always going to do the height times the width. Okay? The height of that rectangle, the way that I find that is that I plug in negative 1 into the function. And then we know the width every single time is delta x, which in this case is 2. Okay, the width of the rectangles, every rectangle is 2. Think about that second rectangle again. How are we going to figure that out? Well, we're going to take the left endpoint, which was 1, we're going to plug that into the function, we're going to multiply that times the width. Think about that third rectangle. Again, what are we going to do? We're going to take the left endpoint, which was 3, plug that into our function, and multiply it times 2. So, when I say plug it into my function, what am I talking about? I'm talking about plugging it in to the original function, which was negative x squared plus 25. So plug negative 1 into negative x squared plus 25, multiply it times 2. Let me show you the actual math on that one. You'd have negative 1 squared plus 25. Whatever that value is, you're multiplying it times 2. Same thing with 1. Negative 1 squared plus 25. Whatever that value is times 2. And same thing with 3. Negative 3 squared. Be careful with your parentheses there. Very important to be careful with your parentheses. And you get each one of these values. So that's going to be the area of each one of the individual rectangles. Go ahead and plug that into your calculator. Let's see what you get. I'm getting 48 is the area of the first rectangle. I'm getting 48 is the area of the second rectangle. And I'm getting 32 is the area of the third rectangle. So how do I find the total? Well, all we got to do is add those three numbers together. When I add those three numbers together, please double check my math, but I'm getting 128. Again, this is area. This would be units squared, but because we're on the XY plane, we don't have a label for units. If this were a real world problem, let's say it was inches or something like that, your answer would be 128 inches squared. Okay, so what is our estimation of the area beneath the curve of negative x squared plus 25 on the interval from -1 to 5 if we use the left endpoint in three rectangles? The answer is 128. Just visually, though, I want you to look at this picture and I want you to think, is this a good estimation? Well, since we already have the picture done, we can look at it. If you see, there's a lot of area where we overestimated. So I'm just going to write a little note here. This is probably an overestimation. Using the left endpoints is not always an overestimation. Sometimes it's under, sometimes it's over, sometimes it could be exact or really close to the answer. Okay, so it totally depends on the function. We can't say it's always going to be over or under. It depends on the function. But this is an estimation of the area beneath the curve using rectangles. Okay, so I guess what my question becomes then is since this was an overestimation, is there a way that we can be a little more accurate? And one of the things that you're going to notice, if you look between these two pictures, if I said which one's more accurate, well, it looks like the left one's an overestimation. Well, to me, visually, because the picture's given to us, it seems to me that the right one is an underestimation. But if I do look at it, it kind of looks to me like this right one might be a little better of an estimation. But let's go ahead and give part B a try here. It says approximate the area of a region bounded by the x-axis of the curve of f of x equals negative x squared plus 25 on the interval -1 to 5 using R6. So again, let's think about that R6. What does R6 means? It means I want to take this interval, I want to break it into 6 rectangles, and with those 6 rectangles, I'm going to get the height of the rectangle by using the right endpoint of all 6 of those rectangles. So the right endpoint is going to determine my height for each of those. Okay? So let's take a look at this. Again, let's think about how many rectangles does it want. It wants 6 rectangles. Okay? Next thing I want to consider is which endpoint do they want? The endpoint they want here, they want us to use the right endpoint. We're going to need to do that. Then we need to know the width of every single rectangle. Again, remember to find the width of the rectangle, you take the right endpoint, which was 5, minus the left endpoint, which was -1, divided by the number of rectangles, which was 6. So this would give me 6 divided by 6, which is 1. So this is our width right here. The width of every single rectangle is going to be a 1. Let's visually, again, this picture is not going to be given to us, so let's visually draw out that number line to see what it would look like. We are using -1 to 5, and we need to make 6 equal rectangles here, so I'm going to have to go in and put in 5 slashes, 1, 2, 3, 4, 5. Try to space them a little bit evenly. Don't worry if your picture is not perfect, but I want you to be able to visualize. This is the x-axis, this is the splitting of the width of every single one of those rectangles. Now I need to label each one of those endpoints. How do I label those endpoints? Well, simply just increase by delta x every single time. So delta x was 1. So I'm going to start at the left endpoint, which was -1. And I'm just going to add 1 every single time. So -1 plus 1 would be 0. Plus 1 is 1. Plus 1 is 2. Then a 3. And then a 4. And then a 5. Looks good to me. I have 6 rectangles. The width of every rectangle is the same. It's 1. So now I need to consider those rectangles. For instance, this is my first rectangle, my second rectangle, third, fourth, fifth, and sixth rectangle. For each one of those rectangles, I need to think about which endpoint am I using. So if I go to that first rectangle, the endpoint that I'm going to be using is the right endpoint to determine the height of it. So if I'm using the right endpoint, I'm going to come in here, I'm going to circle the value. I need to plug in 0. For the second one, I need to plug in a 1. For the third one, I plug in a 2. Fourth one, I plug in a 3. Fifth one, I plug in a 4. And sixth one, I plug in a 5. Again, using the right endpoint for each 6 of these rectangles. So again, to find that area, I need to do the height times the width. Remember, the width is always delta x, which in this case is simply 1, so that's nice because all I'm doing is multiplying everything times 1. So all I need to do is plug in each one of these x values into the original function. The original function was negative x squared plus 25, right? So I'm going to use the table feature in my calculator to help me out on this one. It evaluates it significantly quicker. Again, to use that table feature, hit table on your calculator, clear out the function that's in there, type in negative x squared plus 25, go ahead and hit enter, and then just make sure that you've selected the ask feature, okay? Make sure you've selected ask when you hit enter, once you've entered the function, and then you can type in whatever numbers you wanted. So I'm going to plug in 0, I got 25, plug in 1, I got 24, plug in 2, I got 21, continue on, plug in 3, I got 16, plug in 4, I got 9, plug in 5, I got 0. So that's the height of every rectangle, and then remember we're going to multiply that times the width, which is just times 1. You don't need to show this, but I just want you to remember that you do have to multiply it times the width if the width isn't 1. So the area of the first rectangle, height times width, is 25. Area of the second rectangle is 24. Third, 21. Fourth is 16. Fifth is 9. And the last rectangle actually has an area of 0. So what do I do to find the total area? I add up the area of each one of those individually. Go ahead and do that in your calculator now. Please double check my math. I'm getting a total of 95. So again, this is area. This would be units squared, but because it's the xy plane, we don't have units. So the area of the figure below that figure below the graph of negative x squared plus 25, if we use 6 rectangles on the interval negative 1 to 5, and we use the right endpoint, we estimate the area to be 95. Again, to me, this is a underestimate if we look at the picture right there. So again, I asked the question, is there a way that we could make this more accurate? We use the left endpoints, we use the right endpoints, what else could we do? Continue on to the next page to see some extra examples and a deeper dive.